Good evening. Today we are going to see the problems related with doubly reinforced section. So we are going to solve three problems. So now you can go through this playlist and you can see there are various subjects which are covered under this playlist. So you can see, so these are design of tree structures, but you can see this in same structure and analysis. This is for second year. And for third year, you have 8 videos which are related with your in-same design of reinforced concrete structure. So you can go through these 8 videos. So most of the problems are covered in this for your in-same examination. You can subscribe the channel Civil Engineers Technical Hub if you have not subscribed. So now we will go with these problems. So we have calculated the moment of resistance of a doubly reinforced section and we have size 230 by 400 millimeters. Now we have 5 bars that is 20 mm diameter and 3 bars 16 mm diameter on compression side. We have M30 Fe 250 and cover is 40 millimeters. So now you can see this. So we have this given data. So as 400 we have deep. So if not mentioned, then we have to take it as overall depth. And we have subtracted 40, so we will get 360. So now this AST we can find that is 5 bars that is of 20 mm diameter. And we have this as 1570.8. And this is 3 bars of 16 millimeter diameter. We will get 603.19 millimeters square. And then we can have this XU, because we know basic formula we have, that is 0.36 FCK XU into B plus FSC ASC, and that is equal to 0.87 FY AST. You can go actually, if I will go back and if I will show you, then you can go in detail to understand this, to this design of reinforced concrete structure, and everything is explained in detail in this design of reinforced concrete structures. So now from this I will get actually, so this formula we have modified from this formula, and then we have this XU formula. Now we will assume first, always go with this step, assume 0.87 Fy, we have 217.5 Newton per mm square, and substituting values in this. So we have 0.87 Fy, then AST minus. So this value we have assumed 217.5 into 603.19. It is again ASC, gives us 84.72 millimeter. And then we know we have KU max for Fe 250, and this value we have, that is 0.53. And from this we will calculate XU max. We have 190.80, which is greater than 84.72. So we can say our section is under reinforced section. So we have this as under reinforced. Then we have FSC. If we will substitute values, we got value 369.50 greater than 0.87 Fy. So whatever assumption we have considered, that is correct. And then by using this, we will go with MR value. So now we have, this is 0.36 FCK XUB, this is CU1, so which we have considered over here CU1, and lever arm is D minus 0.42 XU, and this we have, that is CU2. So we have this CU2, and we have second, this is lever arm for this. And by substituting values, we will get value of MR as 110.30 kilonewton meter. Then we have second problem, and in this problem I have considered actually 2 problems, so to cover both the types. So here we have 230 by 425, 5 bars of 16, 2 bars of 12, and M30 Fe 250 as it is cover, we have again 50 millimeters. And now if we will solve this, so we have steps same. If we will go with this XU 68.22 and till this, we have same steps. Now here we have value of FSC. So that is, so actually here we should have this as 68.22 millimeters. And therefore we have again under reinforced. Now as it comes 186.95, so we have to replace FSC, that is in terms of, So we know we have formula for FSC, that is 0.0035 in bracket 1 minus dc upon x, and we will substitute this formula in this basic equation, and from this we will get value of xu. So you can see this. So we have substituted FSC 700 in bracket 1 minus dc upon xu, and if we will solve this equation, we will get it as quadratic equation, and if we will solve this quadratic equation, we will get value of xu. Now we will substitute value of xu in FSC formula, and we have 199.21, which is less than 0.87 fy, and then that is correct one. So now knowing value of FSC, remaining step MR, we are in the same fashion, and we will get value of MR, substituting value of FSC. Here we have just simplified it. We have multiplied 700 into 226.19. We have this value, and then we have separate out this. So XU we have multiplied with this, and then this value we will get 158,333 into 50. And likewise, when we simplify, we will have XU value this way. And from this, again in the same fashion, just I have mentioned. So we have this value, that is CU1, and then we have lever arm related with CU1, and this value we have CU2, and we have this is again lever arm related with CU2. And from this we will get value of MR 74.65 kilonewton meter. So now we will go with third. Now here we have given this data, and we have actually section, if you will see, we have this section 300 by 600, and effective cover we have, that is 50 millimeter on both sides, M25 and FE 500. Now we should be very clear here. For FE 250 we have curve like this, and here we have actually stress is directly proportional to strain, and from this we will get this formula, that is FSC 700 in bracket 1 minus dc upon xu. But if we will go to torque steel, then you will come to know we do not have any definite curve, and therefore we have to use the table by considering these elastic and non-elastic values. Elastic we have, that is stress into modulus of elasticity, and then we have to add elastic strength. This is already explained if you will go to design of reinforced concrete structure. Now this is given data. Now we have to start with, so we will assume value of FSC. How we will assume? So we have to go with this step. First step, we have to assume KU 0.3, and then AST1 we have to calculate. This formula simply we have 0.36 FCK into 0.36 FCK. XU we will write KU into D. 0.36 FCK XU into B, and that is equal to 0.87 Fy AST1. And from this we will get AST1 as 0.36 FCK B KU into D upon 0.87 Fy. We will substitute all values, gives us AST equal to AST1 as 1024.14 millimeter square. AST minus ASC 1700 minus 1100, and we will go KU1 over here. So we have KU AST minus ASC upon AST1. And from this we will get KU 1.18. And using this KU1, we will assume value of FSC, for which we have to calculate value of epsilon SC. Now this XU, we can write it as KU1 into D. So KU1 we have 0.18 and D 550, from which we will get value 0.00173. Now we have this table already. We have seen. If you have any doubt, you can go to the design of reinforced concrete structure playlist, and there you can have this table, how we will have prepared this. Now 173, so I can assume value relate with 174, and that we have 347.8. So I will assume this value as 350. You can assume close to it, and if possible to 5 or 0, that will be end number. And then we will substitute this value, and by using this value, we are going to calculate value of XU, same as we have for FE 250. And that will give us 131.30, and this is less than KU max into D. So now knowing this value, we will find epsilon SC. So that will give us 0.00217. And we have again this table, and in this table, we have 0.00217 between these two, and we will interpolate this. So you can have 0.00195, 369.6 and 391.3 for 0.00226. So we have 369.6 plus 391.3 minus these all values. And from this, we will get FSC 385 Newton per mm square. So first we have assumed this 350 and actually we have this value 385. Now we have to assume value close to this value, not this value. So 385, so I can assume this value, that is 375 Newton per mm square. So this is close to this and this is away from this. So 385, if anyone wants 380 can consider this, you can consider 370 also, that is your choice, but closer is always better to this one. Now we will substitute this value of FSC. So I can say this will be FSC2. And then we will calculate this value by substituting FSC. And we have this XU 121.11, which is again less than 0.46 into 550. Actually, we have this 0.46 into 550, 253 millimeters. And then getting value of XU, epsilon SC we can find. And then again, we can have this FSC value. So we will substitute this value in this equation and we will get 0.00206. Now you can have again, so we have to consider this FSC because we have this epsilon SC 0.00206. So we have to again use these two. And by using this, we will get 375. We have assumed 377.3. We have assumed 375. So it is close. We need not require to go for third trial. Otherwise, you can consider value as 377 and then you can go to the third trial. So that will be very close. And then we can use moment of resistance. So we have this will be again Cu1 into lever arm and this will be Cu2 into lever arm. And from this we will get value of MR 370.73 kilonewton meter. So likewise, we have to solve the problems related with doubly reinforced section for both FE 250 and FE 415 and 500. So if you are not subscribed, subscribe to channel and share these videos to your friends also. Thank you. So now we will stop here.